My topic is on Operation Theatre Safety. Anesthesiologists are responsible for protecting patient and operating room personnel from a multitude of dangers. Some of these threats are unique to the operating room, including the proper functioning of operation room medical gases, fire prevention and management, electrical safety, environmental factors like temperature, humidity, ventilation. Medical gas systems. The medical gas commonly used in operating rooms are oxygen, nitrous oxide, and air. Patients are endangered if medical gas systems, particularly oxygen, are misconfigured or malfunctioned. The anesthesia provider must understand that the source of gases and the means of their delivery to the operating room to prevent or detect medical gas depletion or supply line misconnection. Medical gas cylinders are color coded to prevent incorrect administration of gases. Compressed medical gases use pin index safety system for cylinder to prevent inadvertent crossover and connection for different gas types. E-cylinders have a plug made of wood's metal. These alloys have low melting point, which prevents the explosion with the conditions of unexpectedly high gas pressure in case of unintentional overfilling or during fire. Operating room equipment, including anesthetic machine, connects to pipeline system outlined by color-coded hoses. Non-interchangeable diameter index safety system fitting prevents the incorrect hose attachment. Functioning of medical gas supply sources and pipeline system is constantly monitored by central and area alarm systems. Indicator light and audible signals warns of the changeover to secondary gas sources and abnormal high or low pipeline pressures. Electrical safety. The use of electronic medical equipment subjects patient and healthcare personnel to the risk of shock and electrocution. The physiological effect of electric current depends on location, duration, frequency, and magnitude of shock. Leakage current is present in all equipment as a result of capacity coupling, induction between internal electrical components, or defective insulation. Monitors are doubly insulated to decrease the effect of capacitive coupling. Low impedance ground, that is safety ground wire, divert the current away from a person touching the instrument's case. The operating room power supply can be isolated from grounds by an isolation transformer. Precautions to prevent diathermy burns include proper return electrode placement, avoiding prosthesis and bony protuberance, and elimination of patient to ground contact. Current flows through the heart may lead to the malfunction of an implanted cardiac pacemaker, a cardioverter defibrillator. This risk can be minimized by placing the return electrode as close to the surgical field and as far as from the implanted cardiac devices as practical. Bipolar electrode confine current progression to few millimeters, eliminating need for return electrode. Because pacemaker and ECG interference is possible, pulse or heart sound should be closely monitored when any electrical surgical units are used. Automated implanted cardioverter defibrillator devices may need to be suspended if monopolar cauteries are used. And any implantable cardiac device should be integrated after use of monopolar cautery to verify that its settings haven't been altered by electrical interference. Fire prevention and preparation. Fire is a simple product of chemical and physical properties. The most common risk factor for surgical fire relates to the open delivery of oxygen. Situations classified as carrying high risk for a surgical fire are those that involve an ignition source in close proximity to an oxidizer. When surgical site is in or near the airway and a flammable endotracheal tube is present, the oxygen concentration should be reduced for a sufficient period of time before the use of ignition devices, example laser or cautery, to allow adequate reduction of oxygen concentration at site. Laser surgery airway should incorporate either jet ventilation without an ET tube or appropriate protective endotracheal tube specific for the wavelength of laser. A carbon dioxide extinguisher is safe for fires on the patient in operating room. Carbon dioxide readily dissipates, it is not toxic and not likely to result in thermal injury. A water mist AC rated extinguisher is excellent but requires time and an adequate volume of mist over multiple attempts to extinguish fires. Surgical fires can be managed and possibly avoided completely by incorporating education, fire drills, preparation, prevention, the response to educate to the operating room personnel regularly. Coming to ionizing radiation. Radiation level must be monitored if individuals are exposed to greater than 40 rem, and most common method of measurement is by film badge. A basic principle of radiation safety is to keep exposure as low as reasonably practical. Shielding is the most reliable form of radiation protection. Typical personal shielding in the form of lead aprons, thyroid collars, and leaded goggles is used. Environmental factors in OR temperature. Comfort of operating room personnel must be reconciled with patient care. The ambient room temperature should be maintained between 20 degrees Celsius to 24 degrees Celsius. Impact of operational room temperature on patient core temperature should be monitored regularly. Humidity. Ambient operating room humidity should be maintained between 20% and 60%. Below this range, air dries facilitates airborne mobility of particulate matter, which can be a vector for infection. At high humidity, dampness can affect the integrity of barrier devices such as sterile cloth grades. Ventilation. The operating room should maintain a slightly positive pressure to drive away gases that escape scavenging and should be designed so fresh air is introduced through or near the ceiling and air return is handled at or near the floor level. The National Fire Protection Agency recommends 20 air volume exchanges per hour to decrease the risk of stagnation and bacterial growth. Air quality should be maintained by adequate air filtration using a 90% filter, which filters out 90% of particulate matter. That's all.
Okay. This is more or less what you deal with every day in your OT, from the anesthetic gases to. But any safety issues about the surgery, wrong patient,
Surgical,
wrong side, they
sir,
also
yes,
come under OT safety only. Okay, so
yes,
you
sir.
are also partly
Surgical
involved in
safety
that,
checklist. Yes, sir.
isn't it? So that also has to be included. Otherwise, your answer is fairly good enough. Let's try to show